Okay, we're going to start with CF4, carbon tetrafluoride. Now, the tetra ones tend to be easier when they're set up like this because they work out real well. So first off, if you have carbon, it has to be in the middle. It has to be the center atom. All right, but even if it wasn't carbon, if it was something else here, F4, if you have one of something and multiples of something, generally the one is going to be in the middle anyway. So in this case, carbon's in the middle, and the 4F's surround it. We're just going to put them in a cross shape. Now, what I need to know first is how many valence electrons does carbon have? 4. Okay, so it has 4, and put 1 on each side. And how many does fluorine have? Yeah, 7, thank you. It's all the way to the right there, next to the noble gases and the halogens. So there's a total of 28. So each fluorine has 7. I'm going to put those in as well. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So once I have all the valence electrons in place for each atom that's there, what I'm going to do is I'm going to connect it to the center atom. So I'm going to bond this electron to this one, this one, this one, this one, and this one, and this one, and this one. And then what they're doing is they're sharing. Okay? They're both non-metals, so I can't transfer any electrons, so I have to share. Okay? Now, once I've connected to the middle atom, I have 2 checks that I have to do. One, I have to check that everything has as many electrons as it needs. Most cases, that's 8, but not always. Okay, remember, hydrogen only needs 2. There's cases where we're going to have less and more as well, but for the most part, everything needs 8. And then I'm going to check to make sure the total number is correct, and we said that total number is 32. Okay, so let me go to red here, and we'll count. Okay, 2, 4, 6, 8. That F has 8. 2, 4, 6, 8. That F has 8. 2, 4, 6, 8. That F has 8. 2, 4, 6, 8. That has 8. And then carbon, 2, 4, 6, 8. Remember, the bonds count as 2. Okay, so everything has 8 that needs 8 right now. Now let me delete those real fast. And now I got to count the total. All right, I'm just going to write it in right on top of it pretty much. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So if everything has what it needs, generally again, like we said, 8, and if everything has the total number like it needs, we're done. So in this case, this is what our molecule looks like. Right there. Okay? And that's how you do Lewis structures. Now that's an easier one. There's going to be ones that are harder that we're going to go through as well, but we're going to go through a couple more examples that are fairly easy first. Okay, any questions so far? How do I know what? Because there's 2 there. There's 2 right there. And the bonds also count as 2 because we're taking 1 from each to make the bond. We're sharing 2 electrons among them. Okay? What was your question? For the most part, they're going to be a little bit different. You'll see in a second. Okay, so let's move on to the next one here. Ni3. Okay, so what's going to be in the middle? The N's going to be in the middle. We said that if you have 1 and then you have multiples of something else, the 1 thing's going to be in the middle. In this case, we're going to draw it like a T. Okay, N surrounded by the 3 I's. Okay, next thing I need to look at. How many valence electrons does N have? 5. So I'm going to put 1, 2, 3, 4, 5. How many does I have? 7. So 7 times 3 is 21 total. So 26. So I'm going to put 7 around each I. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I have put the skeleton structure in place, which is just where everything's lined up. I put the valence electrons in. What's my next step going to be? Yeah, I'm going to bond to the middle. I'm going to bond everything to the central atom. So I'm going to bond 2 electrons there, 2 there, and 2 there. Now, in this case, iodine and nitrogen both want 8. All right, so we can count 8 on everything, and then we can count the total. Make sure it's correct. If it's right, then we're done. All right, so I have 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Okay, so everything that has 8, everything that needs 8 has 8. Okay, then I go back and I got to count the total number overall. I'm going to start right here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay, so my totals on both are right. I have 8 on everything that needs 8, and my total number is 26 like it should be. So again, my final structure then, and you don't have to write all these numbers in when you do these. I'm just doing it to illustrate the point visually here. That's what your final structure would look like for Ni3. Okay, questions there? Okay, let's look at the next one. HCN. Now, what here has to go in the middle? The C has to go in the middle. Okay, it's three atoms. Okay, CN separated here. So H has to be on the outside as a rule. C has to be on the inside as the center atom as a rule. So this is basically going to bond almost directly in order. H, then C, then N. Okay, now, first off, how many valence electrons for H? 1. That's going to get 1 dot right there. How many for C? 4. So 1, 2, 3, 4. And how many for N? 5. So my total number at the end is going to be 10. 1, 2, 3, 4, 5. All right, next step is to do what? Combine them. Okay, so I'm going to share those two to make a bond, share those two to make a bond. H only needs how many? 2, and it has 2. Carbon needs 8, but it has how many right now? 6. Nitrogen has how many right now? It has 6 as well. The line is 2. 2 on the outside and then top and bottom. That's 6. Okay, so what I see right there is I have a problem. I don't have 8. So what can I do to get to 8 here? I cannot add another hydrogen. That makes it a different molecule. Yes and no. You're almost right. So what I'm going to do is I'm going to take this electron up here on the top that I just erased and this one here that I just erased, and I'm going to make another bond right here. Make a double bond. Well, now how many does C have? Nope. 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 Count it. 7. How many does N have? 7. Well, they still don't have 8, so what can I do? I can make a triple bond, right? I can take these 2 bottom ones now and make another bond right there. And now we have 8 if we count. If I take this and I count, I have 2 on the hydrogen. We see that easily enough. 2, 4, 6, 8 on the carbon. 2, 4, 6, 8 on the nitrogen. And then from there, I got to count my total. We want our total to be what? 10. 2, 4, 6, 8, 10. So there's my structure. Questions there? Okay, easy enough, right? It's not hard. It's just a matter of following the same steps over and over and over again. Okay? There's going to be times when you can arbitrarily move electrons around too. And it's going to seem really weird, but one of the rules I gave you was if you end up when you're counting, you get 6 and 6, you're probably going to have to make a triple bond. There's going to be times when you have 8 and 6, and you're going to have to pull 2 of the electrons off the one with 8 and make a bond out of that. And you'll see how that happens sometimes just depending on how you draw them, especially when we get to the ions. Okay,